Okay, the first step in working problems where you're taking derivatives of functions that have radicals is that you first have to turn the radical into a fractional power. So for example, y equals 6 over the fourth root of x is the same thing, first of all, as y equals 6 over x to the 1/4 power. And in order to use the power rule, since we don't have a way of dealing with x in the denominator in this section, is we will change that power to a negative and move it to the numerator. And the way that we do that is we change the power from the denominator from positive to negative. So now we can take y prime. And the way that you take y prime using your power rule, remember the way that it works is that you drop the exponent down in front and then reduce the power by 1. So we're going to start out with negative 1/4, and we have now dropped the power. We're going to keep the 6 where it is. It's just like a hitchhiker. It just rides along. And then you have x to the negative 1/4 minus 1. And since negative 1/4 minus 1 is equivalent to negative 1/4 minus 4/4, we keep the denominator, which is 4, and take negative 1 minus 4 and get negative 5. So then our y prime now, the power on x, is going to be negative 5/4. Sorry. And then the next thing that we want to do is we want to take care of negative 1/4 times 6. And that is the equivalent of negative 1/4 times 6 over 1, which is negative 6 over 4, or negative 3 over 2. So then negative 1/4 times 6 is negative 3/2. And you can actually stop there. There's nothing wrong with leaving your answer in that form. If you decide to continue, and again, this is not necessary, then you can take y prime, and this negative 5/4 means the x can go back to the denominator with the 2 and become positive 5/4. And that means that the negative 3/2, the negative can stay in front and the 3 stays in the numerator. And the final step, if you're just determined to do a lot of extra algebra, and again, this is not necessary, is to take that and make it into negative 3 over 2 on the fourth root of 5x to the 5th. But again, you can stop at this step right here, because that actually is a perfectly good answer and has completed all the calculus. So at this point, we have another problem with a radical, but this time the radical is not in a denominator, and we do have an x with a fractional power. So the first thing we're going to do is we're going to write y in an equivalent form as 8 times x to the 1/2 power plus 6 times x to the 3/4 power. And then once we have that, then we will use our power rule to take y prime. So y prime is equal to, drop your power down in front, 1/2 times 8x to the 1/2, but then reduce the power by 1, so that's -1. And then we work on the second term, plus drop the power down in front, 3/4 times 6x to the 3/4. But again, reduce the power by 1. And you absolutely can use your calculator to do your fractional arithmetic if you need to do that. But I'm going to show the steps and how to do this problem. So we have y prime equals, first of all, 1/2 times 8 is 4. And then x, and 1/2 minus 1 is 1/2 minus 2/2, so that makes our answer be -3/2. I'm sorry, -1/2. And that's because, once again, if you have 1/2 minus 2/2, that's 1 minus 2 over 2, which is -1 over 2. So we finished our first term. Now we'll work on the second term. 3/4 times 6 will be 3 over 4 times 6 over 1. And you could cancel and reduce by saying 2 goes into 4 2 times, and 2 goes into 6 3 times, and then 3 times 3 is 9, over 2 times 1 is 2, and you could leave that as 9/2. If it starts in fractions, leave it in fractions. Do not change that to a decimal. So we have 9/2. And that's still times x. And again, then we have 3/4 minus 1 and 3/4. Sorry, my eraser isn't working too well here. Okay, we'll just deal with it. 3/4 minus 1 is the same as 4/4. So we have 3 minus 4, which is -1 over 4. So our power here then on the x is going to be negative 1/4. And at that point, you can stop, because there really is no reason to change any of this to anything else. The only other changes you could make would be to put the x to the minus 1/2 power in the denominator and the x to the 1/4 power in the denominator, but you can actually stop here. This answer is just fine.